Welcome to qnawire.
In this problem, a package slides 2.80 meter down a long ramp that is inclined at 24.0 degrees below the horizontal. The coefficient of kinetic friction between the package and the ramp is given, and we have to find out the work done on the package by friction. So the forces acting on the package are normal force perpendicular to ramp, gravitational force in the vertically downward direction, and friction force will be acting up the ramp because the package is sliding down the ramp. Now the angle of the gravitational force with the direction perpendicular to ramp will be theta, which is equal to the angle of the ramp with the horizontal. So the component of gravitational force perpendicular to ramp will be mg cos theta, and the component of gravitational force parallel to ramp will be mg sin theta. So we have two components of gravitational force. Now we will take the direction perpendicular to ramp as positive y-axis and direction down the ramp and parallel to the ramp as positive x-axis. So along y-axis we have equilibrium because there is no acceleration in the direction perpendicular to the ramp. So in this direction we have forces normal force and mg cos theta, and from equilibrium we have normal force along positive y-axis minus mg cos theta along negative y-axis, and this is equal to 0. So normal force is mg cos theta. Now friction force is equal to coefficient of friction times normal force, so this is mu mg cos theta. Now the displacement of the package is down the ramp and friction force is up the ramp, so angle between the displacement and friction force is equal to 180 degrees. So the work done by friction force is force times displacement times cos of the angle between force and displacement. Cos 180 is minus 1, so we get minus mu is coefficient of friction, mass g, theta is 24.0 degrees, and displacement down the ramp is 2.80 meters. So we get work done minus 38.85 joule. This is the work done by friction. Now for part B, we have to find out the work done on the package by gravity. So on the incline we have two components of gravitational force. One is parallel to incline and down the incline mg sin theta, and the other one is perpendicular to incline, which is mg cos theta. Now the displacement is along the incline, so the component mg cos theta is perpendicular to displacement, which means work done by this component will be 0. So work done by gravity is equal to work done by gravitational component mg sin theta. So force times displacement, and since both these force and displacement are in the same direction, so the angle between them is 0 degree, so this is cos 0. So work done by gravity is mg sine theta times d. Mass is g theta is, and displacement (55.8 joule). This is the work done by gravity. For part C, we have to find out the work done by normal force. So the normal force is perpendicular to the ramp and displacement is along the direction of ramp, so it is parallel to the ramp. So angle between normal force and displacement is always 90 degree. So work done by normal force is 0 because the force is perpendicular to displacement. For part D, we have to find out the total work. So total work is work done by friction plus work done by gravity plus work done by normal force. Work done by friction is minus 38.85 joule. Work done by gravity is 55.8 joule and normal force is 0. So total work done is 16.95 joule. Now we have to find out the speed after it has slid 2.80 meter down the ramp. If at the top of the ramp the speed is 2.20 meter per second. So we will use the work energy theorem, according to which the total work is equal to change in kinetic energy. Change in kinetic energy is final minus initial kinetic energy. Final kinetic energy is the kinetic energy at the bottom, and initial kinetic energy is kinetic energy at the top. This can be written as half m vf square minus vi square, which means two times total work upon mass m. So the final speed is equal to 2 times total work upon mass m plus vi square and square root of this. Total work is 16.95 joule. Mass is 5.00 kg and initial velocity is 2.20 meter per second. So from this we get the final speed equal to 3.41 meter per second. This is the required solution. Thank you.